back to another YouTube video. Today we are testing what would happen if the Earth orbited at different places. So first, we're going to start off with 1 eon away, which is 1 billion years. So you can note its rotational period. Go to years. This is 1 year. We need to go to billion. That's billion. Boom. Instant darkness. At this distance, there's basically no light. That's so far away. That would be so far away. Anyways, I'm going to speed up the simulation and see what happens to poor old buddy Earth over here. So, as we can see, it's not moving very much. Barely even moves. Keep in mind, we're going nearly 7,000 years per second. It's not even moving. Okay, how about 1 million? At this distance, there's a tiny, tiny, tiny bit of light that comes, which does heat it up by the tiniest amount. So what about 10,000 years? Well, now, Earth is heated up pretty good and goes pretty fast now. It's definitely way faster than what we were just at. But how about 100 years? I think this is about the orbit of Neptune, I think. No, it's in like 200 years. I don't know, I think it's about Uranus, and between Uranus and Neptune's orbit. But Earth does heat up quite much. So what happens if we just go down to normal 1 year? Oh, back to normal. It took 5 and a bit million years. But what happens if we went closer? What happens if we went down to a month, okay? What will happen in the first year/month? Earth's temperature is nearly going up by 10 times. Earth's temperature is going up by 20, 30. Let's go up by 100. Will it make it to 100? No, just short. What happens if we made it 10 days? So if you were alive in this situation, you would probably be blinded by the sun. Because if I turn my space goggles off, don't worry, it won't blind you since it's just a computer. Where's that space goggle thingy? I'll find it. It's in here. Oh, wait. So if I turn space goggles, no. Where is it? Oh, there we go. Space goggles off. This is what it would probably look like in the daytime. Pretty bright. Good thing we have space goggles in Universe Sandbox so we can actually see Earth. Okay, now what happens if we go down to 1 day? You can see the fragments chopping off Earth. Alright, let's slow it down. So what happens if I went down into the hours? 10 hours. Okay. So from here, no, there's probably no life. Barely any life, but that's probably the life that lives, like the tiny microscopic life, but it's still going down. So what happens if we went even further? Further, closer. 5 hours. Now we can see Earth starting to stretch from the sun's gravitational pull. What that's telling us is it's so close. If I ever move this even the slightest bit closer, it will, start falling apart and re-healing itself. It's like kind of just like breaking something and then re-merging it. But it does kind of slowly lose mass over time from all the fragments that makes. So now what we're going to have to do is reset the simulation, because also making a new simulation, since it would be a bit hard on another one. We have to shrink down the sizes of stuff. So we're going to shrink it down by 10 times. So Earth will be shrunk down. Its orbital period is nearly 1 hour here. Earth, actually, I don't think we might be able to have to shrink Earth. No, we don't. Just the sun. Okay, let's try that again. But in slow motion. And I'll try and make this as well as possible for you guys, so you can see it properly. Did you just like make the solar system? Okay, well, we're using the solar system now, guys. Put 100,000 kilometers away. I'm gonna put somewhere random. So that's down to 1 second per second, so it's real time. And then I'm just going to do rotational period is 1 day. That's way too much. 1 hour. Oh, it's a bit close. Already, Earth is all the water from Earth getting pulled straight to the sun. And be aware that we're only going about a third of a second. And it's already going up by about 2 degrees, so I'll speed it up a bit more. Oh, laggy. It's getting a bit laggy. So we're going 1 second per second now. Even 1 second per second, Earth slowly moving in its orbit. What about 2 seconds? 4 seconds. Now, accidentally lost this one. Oopsies. Oh. So this is making the atmosphere more thick. So now you can see a more cinematic view of the Earth getting crushed. And there goes a chunk. And okay, guys, we're making a big jump now. We are doing 1 second per second. Yeah, that right. We're going to shrink the sun down to so tiny. It's just heating up. I don't know why. But I'm going to definitely slow this down to a very slow time number. So I don't know how this is going to work out. Compared to the normal sun, by the way, if you wanted to know. So the sun's like nearly as big as Earth. Well, like nearly as small to however you think of it. I think we might have to shrink down Earth as well on this one. I'll shrink it down to 0.1, so this is tiny Earth. I'm just gonna make it 1 minute and see how close we get. Oh, yeah, we can't go 60 times closer. I'm gonna have to shrink it down even further. Can we make that? 60, 30, 15, 10. Oh, can we make 1? Or is it gonna hit? Oh! Yeah, we're gonna shrink down Earth. Shrink down Earth, shrink down Earth, shrink down Earth. 0.001. I think I shrank it down a bit too much, but that doesn't matter. Oh. What the hell? Oh my god, what happened to Earth? It's became like the most rockiest planet of all time. Okay, obviously nothing is happening right now. I'm just gonna put it up to 1 second per second. Okay guys, I think it got destroyed. Maybe it did. Oh. Why is the sun spinning? Why is the sun spinning? What's the sun orbiting? What's the sun orbiting? It's just orbiting nothing. What? That's crazy. Okay. That makes me super dizzy. What? That makes no sense. What? Anyways, guys, I think that's going to be at the end of our video today. Thank you all for watching, and I'll see you in the next one. Bye-bye.